for these organisms.
Conditions on early Earth may have been far worse, but these bacteria suggest that primitive life could have thrived in extremely hostile environments. But where did the very first life come from? For more than a century, scientists have known that life is the result of chemistry, the combination of just the right ingredients in just the right amounts. Today we know these ingredients aren't things like dirty garments and wheat, which people used to think would spontaneously generate mice. The ingredients of life are actually much simpler. All living things, from bacteria to mice to you and me, are made from a small set of chemical elements. Hydrogen, oxygen, carbon, nitrogen, 4 of the most common elements in the universe. Combined in just the right way, these are the fundamental ingredients of life. And carbon is the star of the show.
Carbon's everywhere. It's all over the universe.
What makes carbon special is the kind of bonds that it makes, both with itself and with other elements.
We know of no other atom that has the flexibility that carbon has to form diverse types of compounds.
And the idea that life could have started when carbon and other ingredients combined in the harsh conditions of early Earth was first put to the test in the 1950s by a young graduate student named Stanley Miller. To simulate the newborn Earth in the lab, Miller assembled a contraption made out of flasks and tubes. He filled one flask with gases thought at the time to represent Earth's primitive atmosphere, and he connected that to another flask with water to represent the oceans.
And then he did a brilliant thing. He simply put an electric charge through that to essentially simulate lightning going through an early atmosphere. And after sitting around for a couple of days, all of a sudden there was all this brown goo all over the reaction vessel. And when he analyzed what was in the vessel, now he actually had amino acids.
Amino acids are compounds that form when molecules of carbon and other elements link together. They are the essential building blocks of proteins and cells, vital ingredients of all living things. Stanley Miller's experiment was headline news and jump-started the scientific search for the origins of life.
Life is really chemistry. There's no question about that. In fact, it's a chemistry that when you get the recipe right, it goes, and it goes fairly quickly.
That recipe is hotly debated today. And most scientists think the environmental conditions on early Earth were very different from the ones Miller simulated in his lab. And another debate rages about when this recipe first got cooked up. On our 24-hour clock, the barrage of asteroids and comets lasted from about midnight until almost 3:30 in the morning. The assault then weakened, but continued for more than 100 million years. It's hard to believe that life could have gained a foothold during this unstable period. But new discoveries reveal that life may have existed as early as 4 in the morning, or about 3.8 billion years ago. The evidence comes from some of the oldest rocks on the planet, found in the remote regions of West Greenland.
The geology of Greenland is unique. It contains a record of
some of the earliest geological processes that we know of on the Earth. The rocks themselves are thought to be between 3.7 and 3.9 billion years in age.
These rocks are so old that any fossils they once contained have been destroyed. So, to find out if life existed when they formed, Moisish had to look for evidence that is far more elusive.
There may have at one time been small fossils, microfossils, but under the conditions of heat and pressure that these rocks experienced, such fossils would have been disaggregated and destroyed. So what we have left behind then are chemical fingerprints of ancient bacteria or microbes.
To search for those fingerprints, Moisish first extracts a sample from the ancient Greenland rocks. Then, he will analyze its chemical composition, looking for carbon, a signature of life. But carbon comes in several different forms. And Moisish wants to know if the carbon in this sample is the kind left behind by living creatures. If so, he believes that life may have existed when these rocks formed over 3.8 billion years ago. A controversial claim.
It was a surprise for us to find evidence of ancient life in these rocks. We didn't know if it would be there. You know, just because the stage is set doesn't mean that the actors are present. But these samples here represent the first evidence we have, direct evidence of a biosphere on our planet.
If it emerged so early, life was lucky to miss the greatest cataclysm of all time. An impact like no other in our planet's history. It happened when another rocky sphere about the size of Mars collided with Earth. The outer layers of our planet were vaporized, and the debris from this collision coalesced to form the Moon. That impact was so powerful that any building blocks of life that existed on Earth would have been destroyed. This gives rise to speculation that the ingredients of life didn't form on Earth at all, but arrived special delivery from outer space.
From its size and its appearance, this thing came from outer space. I even have reason to believe that there's some form of life in it.
Hollywood has always been taken with the idea that life came from outer space. But it's not as far-fetched as it might sound.
Space is not very far away. Space is only about 20 kilometers that way. Now that's very close, and space is vast.
And a scientist named Don Brownlee designed an experiment to find out if space might actually harbor the building blocks of life.
There are 40,000 tons of bits of comets and asteroids that impact the Earth every year. This is mostly in form of particles that are less than a millimeter in size. We breathe them, they're in the food that we eat, but they're very difficult to find. You can only find them in very special places.
To see if this shower of space dust contains the ingredients for life, Brownlee needed to obtain samples uncontaminated by Earth's atmosphere. So, to get just a few micrograms of dust, he commissioned a former spy plane to fly close to the edge of Earth's atmosphere. Sticky pads on the plane's wings collected the space dust. Then, Brownlee's colleagues sliced the dust particles into slivers less than 1/10 the thickness of a human hair. And they discovered that these tiny particles